All right, this screencast is going to help you make sense of why we had pancakes in class, and really it's going to start off with our local geology. So here goes. Really, when we talk about our local geology, it's hard to ignore the fact that it has 4.6 billion years of history. But recently, during the Great Ice Age, it was reworked, meaning our surface was kind of broken down and recreated from continental ice sheets that move through here. So when we look at the geologic timescale, this just identifies how recent the Great Ice Age was. It was literally just a blink of an eye, but yet we can't ignore it in terms of how it changed our local landscape. And there have been numerous ice ages over Earth's history, but we're going to talk about the Great Ice Age, the most recent one. So here goes. Over the past 1.6 million years, there have been three primary glacial advances from Canada. So the dark one here, this is what's called the pre-Illinois. This took place between 500,000 to 1.6 million years ago, which is relatively very recent. And the glacial ice advance came out of the northwest. Then we had what's called the Illinoian. The Illinoian came out of the northeast, and it literally supposedly had come through Lake Michigan. And most definitely the Wisconsinian, or the Wisconsin episode, came from the northeast. And this is the most recent one, so therefore the land features are going to result from the most recent glacial advance. So as we look at this, I think it's important to get an idea of what took place within the Pleistocene ice sheet. This is called the Pleistocene Epoch. This is just a part of geologic time where when there was this much glacial ice on the continents, notice sea level was a lot lower. So if you can see the dotted line or the dashed line, that's current sea level, or where the ocean reaches land now, but there was just a lot more land available then. So that's just the result of sea level being lower. So during the Great Ice Age, or when water is in the form of ice, there's less ocean water. So here we can find shoreline deposits and shells at the edge of the continental shelf. And this water was about 450 feet. And these are evidenced by drops in sea level during the Pleistocene. So the Pleistocene is the term referred to from the Great Ice Age. So here we have just a relief map, a topographic map here. And I hope you can see here that we've got all these different rugged contours up in this area here. Obviously we are kind of up in right around here. So we're going to take a look at why that is. So here's just a relief map. You can see that also. See where you see those deep valleys? That's where rivers cut through. So here's a river valley, and here's a river valley. So the two primary river valleys that cut through Illinois. So if we were to look at the Great Ice Age from space, you would see that these are continental ice sheets that are flowing out during the Pleistocene Epoch, right, the Great Ice Age. So glaciers spread from one or multiple locations. Such solid ice spreading flows like a fluid in all directions under its own weight. So what happens if I build up enough depth of ice, over time it's going to begin to flow. So many of you right now should be thinking, wait, what? Yeah, exactly. So this is why we made pancakes. If I have pancake batter that I pour right here, that I pour right here, and that I pour right here, just three major locations of what are called the Zone of Accumulation. The Zone of Accumulation is simply one focal point where snow and ice built up to a certain depth, and then the ice flowed from that point, just like a pancake would. So if I poured pancake batter here, it's going to flow out in all directions. Well, we just happen to be in the path of that flowing ice, which was a continental glacier. So the idea of why we made pancakes is for you to get the concept of that flowing pancake batter is much like that of glacial ice. So notice we've got two what we can call focal points or zones of accumulation that influenced our local landscape. And there's names to them. We had the Labradorian center, this is to our northeast, and we had the Keewatin center. So these are the two that influenced us. That glacial ice literally accumulated so deep that the ice began to flow from under its own weight. And that's actually very common. That's not uncommon. Glacial ice at a depth of about 65 feet will flow outward. And that's what a glacier is. And that's really what a continental glacier is. So if we can go back in time and be a little creative here, glacial ice was flowing. It was traveling fairly slowly, several feet per day. But over time, it's going to erode and then kind of redeposit sediment on our landscape. So when I go back to this here, you should be able to realize that the most recent one from the Wisconsin, from 10,000 to about 30,000 years ago, this is the most recent one. So when we took our field trip, we drove over all of those moraines, right? Those moraines actually had formed as the glacial ice was retreating. We'll look at that in just a moment here. So here, these are just the three major advances and retreats. Notice that this here is older than, and it's getting younger. This was a younger retreat, and this was even a younger retreat yet. So what happens here is we're simply following the geologic story of our local landscape of Northeast Illinois. And here's what it looks like. These are the moraine systems, and we drove over these, right? The Deerfield moraine was one. We've got the Blodgett moraine, and we had the Highland Park moraine. These are those three lobes that you see right here that we drove over. So all of these moraines here are consistent with that glacial ice literally flowing out from where Lake Michigan currently is. And if you notice, if you were to draw a line perpendicular to these curvatures, glacial ice was retreating in a direction that's considered perpendicular, and if you line up all those perpendicular lines, glacial ice would have retreated to the northeast. So there's a geologic storyline to all that as well. So here's a picture, just to kind of get an idea of what took place. There's an ecological succession that took place, and I'm not going to beat you up on this, just to make sure you realize that we get our plants, our botanicals, from a lot of different areas. Particularly, we can look to the west. Wisconsin and Iowa influenced what trees and what organisms moved into this area. Here's a landscape, a picture from different soils, to where these are just different erosional surfaces. And what happened here is these are just different sedimentary layers that are actually consistent with like unconformities. When I say an unconformity, we just have a layer of erosion here. So this would have been the pre-Illinois, this would have been the Illinoisan, and this would have been the Wisconsin glacial episodes. So it's kind of cool that these still exist today, but it's not old enough to have formed rock. So all in all, when we go back to thinking about what took place here, I want you thinking about the concept of geologic time. Very recently, the planet went through the Great Ice Age. It influenced our local landscape. There were three primary glacial ice advances. The most recent one was called the Wisconsin. That's the one that influenced us the most, or let's just say more recently. And the reason why we ate pancakes is that when I put pancake batter on the hot skillet, it's going to flow outward, and that's the same concept, the analogy for how and why glaciers advanced from Canada into our local landscape. And as a result, it reworked our landscape, recreated different lands and different soils, and if we were to dig down in our land locally beneath us, we would find a really, really deep layer of Wisconsinian soil, and yet beneath that we would have what we could call an unconformity here. And underneath that unconformity, we would find rock that's about 400 million years old. So that's missing about 400 million years of geologic time from the unconformity beneath our soil, beneath our feet. Kind of cool, kind of unique, kind of different. There you are.